The example that I showed in the previous module may have given you the false impression that indexing into an input array is easy. But that's because we only used something very simple. In actual fact, if we want different elements to be processed in parallel, we need to sort of map our thread space to the input space. So this is a real problem because effectively, the thread space can be up to 6 dimensions. As I say, you can have 3-dimensional grids of 3-dimensional blocks, and you need to somehow map this to an input space which is typically 1-dimensional, even though strictly speaking you can use 2-dimensional arrays in CUDA. It's not something that I would recommend because things get a bit messy, and it's just easier to map things to 1D arrays. And you would notice that when people process images, for example, in most cases people use 1-dimensional arrays to represent images, even though strictly speaking an image is something that you might think is inherently 2-dimensional. So we have this problem. We need to map inputs to threads somehow, and this obviously depends on the kind of dimensions that you have specified for the kernel execution. So here are some examples of what one would have. So let's start with the first one. So you have one block of n threads, and this is easy. This is something that we've done previously because you can simply take the x value of the thread index and you have this 1-to-1 correspondence. Now imagine that the block, you still have one block, but the block is 2-dimensional. So what you do now is you take the dimensions of the block, multiply them by the y-coordinate of the thread, and add the x-coordinate of the thread. So this is similar to the way that you would index into a 2D matrix if you had just the 1D array to deal with. And the same idea obviously works if instead of having m by n threads, you have n blocks of m threads. So it's a similar idea except that you use the grid dimension instead of the block dimension. So it's kind of like running multiplication, and obviously for 6 dimensions, it's a rather large multiplication. And in one of the patterns that are to follow, we'll actually look at how you would index into a 6D array.